Hey guys, here we are with 1.6 notes on inequalities, and we'll be working with some more with absolute values. So far we've done inequalities individually, like graphing x is greater than or equal to -4 on a number line, graphing x is less than 3 on a number line. Okay, today we're going to be looking at compound inequalities, more than one inequality going on at the same time. So a compound inequality containing and is true if and only if both inequalities are true. So if this was an and, so we're going to graph these. What I'm going to do is I'm just going to graph these both individually, and then we'll see where they overlap. So x is greater than or equal to -4. So I would have a closed dot going this way. Arrow over here. Kind of running out of room there, hitting my computer. And x is less than 3. Open dot going this way. So where are they both true at? Where are they both true? Where do they overlap, basically? So we're looking at they're both true between closed dot at -4 up to an open dot at 3. That's where they're both true. All these numbers inside here, including -4 and up to, but not including 3, are both greater than or equal to -4 and also less than 3. Alright? So and is usually between something. Okay? Sometimes it's written out like this. 8 is less than 3y minus 7 is less than or equal to 23. They've got it all on one line. Okay? All written down at once. So when we're solving these, we got two options. Number one, we can solve them separately, or number two, we can do it together. Alright, so we'll look at separately first. So for separately, we're only going to look at this one first, and then we're going to look at this one, and then we're going to put it back together. So I'm just looking at the left side of it. 8 is less than 3y minus 7. You would add 7. And we're going to have 15 is less than 3y. We would divide by 3. We'd get 5 is less than y. Usually we have the letter on the other side, so be careful here. You just can't flip that. You got to take like the whole thing, right? So if it was my pen, I would have to take the whole thing and flip it over like that. Right? So the greater than still needs to be by the y. So if I did y greater than 5. See how the less than is still pointing at the 5. The open side here is still pointing at the y, so it's still the same thing. Okay? On this side of it, we would need to add 7. And then divide by 3. Y is less than or equal to 10. Okay? So if you're looking at it like this, we can kind of put them both together, back together right now. 5 is less than y is less than or equal to 10. So it's going to be between 5 and 10. Sometimes it doesn't work out like that. Sometimes like this is going to be a negative and this number on this side is going to be smaller and you might need to turn it around. Otherwise, if you're going to graph them individually like we did up on top, you can do the greater than 5. We'll just do a quick little sketch down here. 5 and 10, greater than 5, less than or equal to 10. Alright, and we're going to be right here in the middle. So this is going to be our final answer, where they're both true. Okay? What if we did it together? Alright, and we can do them both together for these compound ones that are an and. Alright, when it's all in between. So just like solving an equation, or just like we did over here, whatever you do to one side, you have to do the other, except this time there's 3 sides and not just 2. So now when I add 7, I have to add 7 to 3 parts. Okay, and you'll see back here, that's what we did. I added 7 here, I added 7 to that side, but that was also the first step on this side, was add 7. Okay, 15 less than 3y less than or equal to 30. All right, and now 3y, so divide everything by 3. Be careful with your inequality signs. Don't get lazy and let one like less than turn into a less than or equal to, or let your less than or equal to turn into a less than. You gotta stay alert on those. All right, and now there we go. So I like doing it this way. Some people just before with a previous teacher, they've split them apart, and that works out well for them, and that's what they've done before, so that's great. You can keep doing that. Otherwise, if it gives it to you in one piece, I like to keep it as one piece. Okay, graphing that, now it's really easy. 5, 10, open circle at 5, closed circle at 10. All right, and there we go. All right, so if it gives it to you like this, an and, where it's going to have it in between, you're usually going to be just in between. All right, it's a really easy way to kind of think about that. An and or a between one is just in between there. Okay, you can always do it separately and double check where do they both overlap. All right, moving on. An or, a compound inequality containing or, is true if and only if one or more are true. Okay, so we just need to have one of them. It doesn't have to be where they overlap, just where either one of them is true. All right, so greater than or equal to 5 or less than negative 3. All right, and that's the answer. Either way there, okay? If that would have been an and, then there would have been no overlap and there'd be no solution. This is an or, so it doesn't matter. Either this one has to be true or that one has to be true. So as long as one of them is true, we're good. Okay, so that's why it goes out. How I remember that is or usually forks out. Or usually forks out. Now there are going to be some crazy ones that overlap, and then the answer is just going to be all real numbers, because if it's an or and they overlap, then you're going to use every number. Okay? All right. Now, absolute values and inequalities. Okay? Absolute value of x is less than 3. Remember, we talked about the absolute value of x is the distance a number is from 0 on the number line. So this is saying the distance from 0 on the number line is less than 3. So where are all the numbers on the number line that would be less than 3 units away? Okay. So negative 3, and it's a less than, so we're going to use open circle. Negative 3 is 3 units away. Less than would be all these numbers down here. Negative 2, negative 1. All right, those are all going to be less than 3 away from 0. On the other side, positive 3 is also 3 units away from 0. And then as we come in, we're getting less than 3 away. We're getting closer. So 2, 1, okay? So we can see that all the x's whose distance away from 0 on the number line is less than 3, those are going to be between negative 3 and 3. So an absolute value with a less than sign is like an and. It's like an and. Absolute value and a less than sign is like and. We need x to be less than 3 and x to be greater than negative 3. How can we flip it to greater than? because we went from x is less than 3, and then we did greater than, so I flipped the sign to a greater than, and I changed this to a negative 3. Or you can look at it as I changed this to a negative 3, and we know our rule with negatives and inequalities, we flip it. So because I changed this number to a negative 3, I flip the inequality. Alright, so x is greater than negative 3, or negative 3 is less than x. And we could put it together, you could write it like that as 1 unit if you wanted to do that, between negative 3 and 3. So these are probably the toughest ones. You just got to remember that absolute value, less than, that's going to be a between one, an and, okay? Absolute value of x is greater than 3. So think about what absolute value is. Again, distance from 0 on the number line. And our distance from 0 is greater than 3, is more than 3. Alright, so again, negative 3 is exactly 3 away. More than 3 units away, we're going to be going out, away from it. And 3 is also 3 units away from 0. We want the distance to be more than that, so we're going to go out and away from it. So again, now we have an absolute value with a greater than symbol, and we're going out. We're forking out, a fork, or, okay? Absolute value with a greater than is like an or. X is greater than 3, or, this got cut off on the copier, didn't it? We would have x is greater than 3, or x is less than negative 3. And why did we flip that sign? Because this was greater than. Why did we flip this to a less than? Because now we were talking about negative 3, so flip your sign. Okay, so that might be, this is usually pretty tough to get in, to settle in your brain. So you might need to rewatch that again. Maybe it might make more sense after we do an example problem here. Okay. Absolute value of 6x minus 5 greater than or equal to 13. Alright, what do we do? What do we do? Okay, it's a greater than or equal to, greater, we just did that, greater, greater, it's like an or, it's going to fork out. Okay. Think back to lesson 1.4, where we solved inequalities, okay? So we have the inequality box by itself, and now we're ready to split. So we're going to have 6x minus 5 is greater than or equal to 13, or, okay, 6x minus 5, and we're going to change this to a negative 13 now, and because we changed it to a negative 13, we're going to flip this sign from a greater than or equal to a less than or equal to. Alright, solve each one individually. Plus 5, plus 5. 6x is greater than or equal to 18. Divide by 6, divide by 6. X is greater than or equal to 3. Alright, or, on this side now, to solve this one individually, plus 5, plus 5. 6x is less than or equal to, negative 13 plus 5, negative 8. Divide by 6. X is less than or equal to negative, we can reduce that to 4/3. Okay, now how can I graph those on a number line? So here's going to be 3, greater than or equal to, solid dot, going out to the right, greater than, bigger, so 4, 5, 6, 7. Less than or equal to negative 4/3, we'll put that over here. Okay, and since we're drawing our own number line, we can just pick the number, negative 4/3. You don't have to do like negative 1, negative 2, and put that in the middle of it. Less than or equal to, so solid dot going smaller, negative 2, negative 3, negative 4, negative 5. It's an or, so it's forking out, and there we are. Okay, those are tough, guys. It's just going to take practice and getting used to them. We'll try to do a couple more of those in class. If we have questions, we'll get through some of those. All right. Absolute value with a less than. 2x plus 1 is less than 7. Okay, think about what we just talked about. Absolute value with a less than is kind of like a between one. It's an and. Okay, so these are actually really nice. These are actually really nice because now here's what you can do with these is you can just drop the negative 7 on the other side. All right, so we can do that. This is what we had. Okay, 2x plus 1 is less than 7, and if we were to do the other one, it'd be 2x plus 1 negative 7. We'd have to flip the sign, so we just need 2x plus 1 to be greater than negative 7, and that's what this says. So the absolute values with a less than are actually pretty okay to set up, because all it is usually is just taking this negative on the other side like this. We're going to do a between. Okay, subtract 1 from all 3 parts. Okay, divide 2 on all 3 parts. And there we are. We're going to be between negative 4 and 3. Open circle. Open circle. Okay. So we're going to be between negative 4 and 3. All right, let's say that we didn't do the between one. Let's say you split it up. We got 2x plus 1 less than 7 and 2x plus 1, we did negative 7 and we remembered to flip it to greater than. All right, so we would subtract 1, divide by 3, divide by 2, excuse me, the answer is 3. Okay, over here, subtract 1, 2x greater than negative 8, divide by 2. Okay, so we have 2 individual ones. X is less than 3 and x is greater than negative 4. So you would maybe test this out. You're going to go, here's our negative 4, we're going greater. Here's our positive 3, open circle, we're going less. Where do they overlap? Between. Okay. And that would get us the same thing. Open circle, they both overlapped right there between them. Okay. Let's say, here's just some real special cases, guys, that don't happen a lot, but just in case they pop up, just to be aware of them. If you had an and, right, and our ands, we're normally looking for where do they overlap, just like what we had right there. Where do they overlap? Okay, and that's where our thing was. What if it was an and they went out, away from each other? Okay, well, it's an and for whatever reason they just went out, away from each other. All right, they don't overlap. There's no numbers where this one and this one are both true at the same time, so then we'd have a no solution. Okay, or another one, for an or we're used to seeing, right, we're used to seeing forking out, like out or fork out, so that's okay. It's this one's true or this one's true, okay, so there's no problems. What if, again, there's no problems with this one, but it's just a weird one. What if it was an or and they crisscrossed? Okay, so then this one would be just a straight line, because this goes this way forever and this goes this way forever. All the numbers are true, so then we could just do a straight line. So that's just kind of another special one there. Okay? And we'll take any other special ones that come up as we go, but those sometimes pop up. An and that doesn't overlap is going to be no solution. Or an or that does overlap is just going to end up being a line, because every number would work. So just some special ones to be aware of, guys. All right? Good luck there on your homework. Let me know if you have any questions, and we'll see you in class.